Good morning, student. Today it's the fourth day of ABL 3 and under the total quality management theme, we will be discussing about 7 basic tools of quality. So the 7 quality tools for process improvements will be discussed in detail today. The quality tools are more specific or the tools which can be applied to solving problems in improving quality in organizations, manufacturing, or even in individual processes. They were first emphasized by Koru Ishikawa, professor of engineering at Tokyo University and father of quality circles. Where did the quality tools originate? The 7 quality tools were originally developed by Japanese professor of engineering Koru Ishikawa. They were implemented by Japan's industrial training program during the country's post-war period as it turned to statistical quality control as a means of quality assurance. Their goal was to implement basic user-friendly tools that workers from various backgrounds with varied skill sets could implement without extensive training. Today, these quality management tools are still considered the gold standard for troubleshooting a variety of quality issues. They are frequently implemented in conjunction with today's most widely used process improvement methodologies, including various phases of Six Sigma, TQM, continuous improvement processes, and lean management. So these 7 tools are stratification, alternatively it's called as flowchart or run chart, histogram, check sheet, cause and effect diagram, also known as fishbone diagram or Ishikawa diagram, Pareto chart, scatter diagram, control charts, and bonus or the flow charts. 7 basic tools are listed over here. So we'll go one by one. The first tool is stratification. Stratification analysis is a quality assurance tool used to sort data, objects, and people into separate and distinct groups. Separating your data using stratification can help you determine its meaning, revealing patterns that might not otherwise be visible when it's being lumped together. Whether you're looking at equipment, products, ships, materials, or even the days of the week, stratification analysis let you make sense of your data before, during, and after its collection. To get the most out of the stratification process, consider which information about your data sources may affect the end results of your data analysis. Make sure to set up your data collection so that the information is included. On the right side, you can see that there are 3 groups of data, group 1, group 2, group 3, which are scattered and between the variable x and y axis. So they are static, they are basically segregated. Histogram. Quality professionals are often tasked with analyzing and interpreting the behavior of different groups of data in an effort to manage quality. This is where the quality control tools like histogram comes into play. The histogram can help you represent frequency distribution of data clearly and concisely among different groups of a sample, allowing you to quickly and easily identify the areas of improvement within your processes. With a structure similar to a bar graph, each bar within a histogram represents a group, while the height of the bar represents the frequency of data within that group. Histograms are particularly helpful when breaking down the frequency of a data into categories such as age, days of the week, physical measurements, or any other category that can be listed in chronological or numerical order. So you can see that these are the histograms, and the height of the histogram will tell you the frequency of that particular data, and they are grouped into various groups. Check sheet or tally sheet. Check sheets can be used to collect quantitatively and qualitatively data. When used to collect quantitative data, they can be used as a sheet. A check sheet collects data in the form of check or tally marks that indicate how many times a particular value has occurred, allowing you to quickly zero in on the defects or errors within your process or product, defect patterns, and even the causes of specific defects. With its simple setup and easy to read graphics, check sheets make it easy to record preliminary frequency distribution data when measuring out processes. This particular graphic can be used as a preliminary data collection tool when creating histograms, bar graphs, and other quality tools. So one can see these check sheets here in a tally form. Cause and effect diagram, also known as fishbone or Ishikawa diagram. Introduced by Kuru Ishikawa, the fishbone diagram helps users identify the various factors or causes leading to an effect, usually depicted as a problem to be solved. Named for its resemblance to a fishbone, this quality management tool works by defining the quality related problem on the right hand side of the diagram, with individual root causes and sub causes branching off to its left. A fishbone diagram causes and subcauses are usually grouped into six main groups, including measurements, materials, personal, environment methods, and machines. These categories can help you identify the probable source of your problem while keeping your diagram structured and orderly. So on a large scale, if we see this is measurement, what are the lack of tracking of this measure errors in the measurement can be listed here. Material that is incorrectly packaged product or wrong item number on product. Method that is inconsistent onboarding program or orders not verified. So these are sending incorrect shipments. And here we have environment where it can be low attention to detail, hazardous work environment, for example manpower that is tired workers or untrained employees who could not do their work properly, machinery, software bugs or no packing list, etc. So these are the reasons for analyzing the errors in the system. Pareto chart, that is 80-20 rule. As a quality control tool, the Pareto chart operates according to 80-20 rule. This rule assumes that in any process, 80% of the processes or system problems are caused by 20% of major factors, often referred to as vital few. The remaining 20% of the problems are caused by 80% of the minor factors. A combination of a bar and a line graph, the Pareto chart depicts individual values in descending order using bars, while the cumulative total is represented by a line. So the goal of the Pareto chart is to highlight that relative importance of variety of parameters, allowing you to identify and focus their efforts on the factors with the biggest impact on the specific part of the process or system. So you can see here the frequency versus the time. It's a combination of a bar and a line graph where this is individual values in the descending order and the cumulative total is given out as a line over here. Scatter diagram. Out of the 7 quality tools, the scatter diagram is most useful in depicting the relationship between two variables, which is ideal for quality assurance professionals trying to identify cause and effect relationships. With dependent values on the diagram's y-axis and independent values on the x-axis, each dot represents a common intersection point. When joined, these dots can highlight the relationship between the two variables. The stronger the correlation in your diagram, the stronger the relationship between the variables. Scatter diagrams can prove useful as a quality control tool when used to define relationships between quality defects and possible causes such as environment, activity, personal, and other variables. Once the relationship between the particular defect and its causes have been established, you can implement focused solutions with hopefully better outcome. So here you can see the variable versus variable y versus variable x, where this is a dependent one, this is an independent parameter, and it will show you a particular defect relationship with the cause. So you can see in these scatters, all these lines when they are intersecting, you can have a solution to the focus problem. Control chart, also called as Sheward chart. Named after Walter A. Sheward, this quality improvement tool can help quality assurance professionals determine whether or not a process is stable and predictable, making it easy for you to identify factors that might lead to variations or defects. Control charts use a central line to depict an average or mean, as well as upper and lower line to depict upper and lower control limits based on historical data. By comparing historical data to data collected from your current process, you can determine whether your current process is controlled or affected by specific variations. Using a control chart can save your organization time and money by predicting process and performance, particularly in terms of what your customer or organization expects in your final product. So you can see over here the number of occurrences versus the sample number. This is your control. This is control central line. This is upper control limit, and this is a lower control limit over here as it is set. And red colors are out of control and white color dots are in control points. and therefore you can use this control chart to analyze the processes. Bonus of flowcharts. Some sources will swap out stratification to instead include flowcharts as one of the 7 basic QC tools. Flowcharts are most commonly used to document organizational structures and process flows, making them ideal for identifying bottlenecks and unnecessary steps within your process or system. Mapping out your current process can help you to more effectively pinpoint which activities are completed when and by whom, how processes flow from one department or task to another, and which steps can be eliminated to streamline your process. So you can see the sample of a flow chart over here. So we have discussed all the 7 tools, basic tools for quality assurance. And this is what is the last one which we'll be talking about. Let Lucid Chart help. Lucid Chart's intuitive diagramming software provides all the tools you need to complete each step of process improvement and quality assurance, from identifying the possible causes of various defects to implementing time and money saving solutions. Will help you create effective, shareable quality tools in minutes, and then turn your result into actionable goals for you and your team moving forward. And you can see the diagram which is depicted over here. That's all for today. Thank you so much.